Okay, so name of the talk is Taming Skynet, not Stuxnet. I apologize, it was misprinted for whatever reason. There will be no Stuxnet talk here. So Skynet, the wonderful AI from Terminator. So we'll start out with who am I? I'm not a security guy. I don't work in security. This is kind of a side hobby for me. And this is actually my first con talk, so I'm nervous, and you people terrify me. I'm Jason. You may know me online. Twitter handle is Xenophage. I kind of bounce around a whole lot of different things. Mainly, my day job is as a senior network engineer for a small liberal arts college in Pennsylvania. I get to build a fairly decent-sized network and deal with a lot of students who don't care about anything that's on their computer. So lots of malware and all sorts of other good stuff. So if I'm not a security guy, why am I here and why am I talking to you? I'm here to learn, just like you guys are. I was told a long time ago that one of the best ways to learn is to actually try to teach. Forces you to kind of do some research and learn something. So I learned something, I'm doing something, and I want to talk about it. So let's get started. Taming Skynet. It was a catchy name. It sounded cool when I came up with it. I think it's neat. So why Skynet? Skynet is the ultimate in cloud. I mean, we're talking about a cloud so secure, this thing is after you. It's going to kill you. So all of this cloud technology that's out there now, it's basically out of our control directly. This is somebody else's computer. It's their playground, and we're just kind of in it. We don't really have any direct control over things, but maybe we can do something useful with it. There's a lot of really, really smart people who built this stuff. Some of us like it, some of us don't, but maybe there's something useful there. So this is born out of a talk by Mick Douglas, Better Safety Net, last year. His talk was Blue Team is Sexy. Got me kind of thinking, I am the blue team, so I might as well try to act that way. So I've spent about a year now kind of tooling around, playing with some different things, came up with this talk, decided to give it a shot. Didn't expect to get accepted, and I did. So if I can do it, you can. So have a talk next year. So the cloud. Yes, we're talking about the cloud. That cloud that everybody knows about. This is religious territory. I'm aware of that. Some people like the cloud. Some people don't trust it. Personally, I try to kind of avoid putting my stuff there. But first we have to define what cloud we're talking about. The cloud itself is kind of a weird term. It's come up a lot, and for a long time at work there was a lot of debate about what we're talking about when somebody says the cloud. Because the board members come down and say, hey, why aren't you guys using the cloud? And we say, what does that mean? There's a lot of different types of technologies that are categorized as cloud technologies. You have storage areas such as Dropbox. Some people came up with, I believe it was called Google Drive, using Gmail for storing files. You have hosted VMs, Amazon's AWS. There's others out there. Microsoft makes one that nobody uses. Hosted applications, Salesforce, other such, why should I have an IT team do it for me? I'll just let somebody else do it. For this talk, we're looking at running our own code, so we're probably more interested in a VM type architecture. And why? Well, it's there, somebody has to use it, and it's kind of inexpensive. So I can pop up my own server, but for what we want to do, we don't want to host it ourselves. We don't want it inside of our network. And if you want to host a server somewhere else, I mean, we're talking physical server here, it can get expensive pretty quick. Amazon's AWS is pennies a day, if that. So it's a pretty good piece to use. Which cloud are we talking about? Well, if we're talking public, I'm talking things like Amazon AWS, Windows, Azure, other such cloud providers. There are private clouds. CloudStack is one of them. But again, this is something you're going to host yourself. It has its purpose, and we'll talk about that. But kind of what I'm looking at here is not necessarily something that's inside of my network. So now we have a cloud. What are we going to do with it? We're going to scan all the things. We're talking about baselining here. So first we have to kind of understand what baselining is. So I went to Google and said, what's baselining? And Google said, a minimum or starting point used for comparisons, which was a fair definition. Did some more poking around, and I found this one I like a little bit better. Normalized view of the network used to detect anomalous activity. This is exactly what I'm talking about here. Why are we baselining? Baselining gives us a very easy way to look at our network from the perspective of an attacker. And we're talking about an outside attacker, trying to get directly to systems that are exposed to the internet. Seeing what's inside is a little bit different, although baselining will help you there a little bit too. So we're looking at, let's take a look at our network, let's monitor that, and let's see what changes. Maybe you run a scan on your network and MySQL is open. Well, that's probably not a good idea. You may find that there's machines out there you didn't even know existed. It, at least at the very beginning, gives you a really good view of your network where you can say, this is what I have. Excuse me. It can also provide historical network data. Now, some of us are very data-driven. I know I track probably way too many things about myself, weight, what I eat, when I exercise, et cetera. For management, they like numbers. They like seeing graphs and pretty things like that. So being able to get historical network data, how many hosts did I have today compared to last week, compared to the week before? You can actually see your network grow and change over time. You can see services come and go. So it gives you kind of more of an insight into the network. And there may be other aspects of this data that you can use as well. I'm just starting to explore a lot of this, so a little bit new. You get intelligence on your network. Again, we're looking at this from the outside. So this is what the general public is going to see on your network. So this is what the script kiddies are doing. They're scanning your network. HDMore is scanning your network a lot. And this is something that is pretty easily automated. And it's a sort of a silent type thing. It's not going to alert you unless you make changes or unless changes are made without you knowing. So it's not going to inundate you with lots and lots of mail. Well, unless you want it to. I don't like mail, so. Like I said, we have two different types of scanning. We have in-network scanning. In-network scanning is not going to give you a public view. Obviously, you're in your own network. And depending on how you've configured your network, how you're laid out, hopefully you have lots of different networks. It can become difficult at best to get a view of what's going on. So, for instance, from my administration network, I can see everything. That's kind of the point. From, say, the student network, I should see basically what the public can see, maybe a couple extra things. But getting servers or getting processes to run inside those networks may not be easy. There's business logic to contend with. It may be policy that you can't run servers on certain networks. And in those cases, how do you scan from those networks? You can do it manually. That takes a lot of time. But how would you automate something like that? And that's something that I'm still thinking about trying to figure out. Even just getting a server onto those networks is sometimes difficult. Then you have your out-of-network scanning. This is where the kiddies live. This is where the majority of your attacks are probably going to start. You've got insider attacks. You have to worry about those as well. But for what I'm looking at least right now, it's from the outside in. Let me see what I have on my network. Let me try to get a good grasp of what's there and then defend when I can. So, what am I proposing? I'm proposing new firmware for Skynet. So we have a cloud component. This is the actual Amazon piece or the insert cloud here piece. The basic idea is that we want to scan the network. Nmap seems to do a pretty good job of this, so we might as well use it. We're going to need some scripting around this, something I'm just calling the local spawning daemon. This will run Nmap with whatever options that you need on a timed basis. Something that I have been kind of poking around at is we can encrypt the results on when we're done. I don't know how much extra security this gives, kind of just playing it by ear. It's pretty simple to do, simple PKI, GPG encrypt type thing. Maybe necessary, maybe not. On the back end, you have a control system. This is where you would set all of your scan times, your options, et cetera. And then this is what's responsible for retrieving the data. Again, your script kiddies are already doing this. They have this data, but let's not just hand it to them. So why don't we pull that off the remote system that we've done the scanning on and then delete it when we're done. So don't leave anything out there that we don't need. A visualization system so that we can see what's going on. This is just a generic web-based type GUI. Look at the past reports. This would be where you would go to make changes to the system, and it can make pretty pictures for the management so they can understand what's going on. Reporting system, this is basically automated, mostly email. Again, you can view this stuff through the GUI, but this is where you would get your daily reports, assuming that's where you want to go. So come up with a bunch of predefined reports like these things changed, these things didn't change, et cetera. You can set it up so that there's no changes, no report. Pretty straightforward, pretty simple. Because I'm a hacker, I like CLIs. I don't like GUIs, so one of my prerequisites is having a CLI for this thing. Everything in our network that we enjoy using seems to have a CLI. We try to use that and script that. It makes it a little bit easier. Same capabilities as what you can do in the GUI. Generating graphs via CLI, I guess you can probably do that. I don't know how much use that's going to have. Maybe we do it in ASCII. And then security of the tool itself. So like I said, we can encrypt scan results. I don't know how much benefit that gives us. There's already tools out there for securely connecting to remote networks, SSH. Maybe you guys have heard of it. Might as well use that. It's there. I'm not a cryptologist. I don't think I can do any better. And then scrubbing any data that's there. Now, this becomes an interesting piece because you don't have control over what's out there. And you don't know if Amazon is backing data up. Maybe they are, maybe they're not. Maybe you'll get an email that says that your VM is gone. But best practice is say, might as well scrub the data if you don't need it at the time. And I'm probably missing things that we can do. We can talk about that. You can send me an email, tell me, maybe you need this piece, et cetera. This is something that I'm in the process of building, so any additional suggestions are definitely requested. The back end, so we can get into a language war. I've chosen to do this in Python for all of the CLI-based stuff, all of the logic, et cetera. I was a Perl hacker for a long time. It works great. It's wonderful. I want to learn something new. Python seems to fit that. So all of your CLI tools, your control daemons, et cetera, would be written in Python. And then for the GUI front end, PHP seems to fit. So like I said, this is what I know. This is what I'm going to use. Then you have the data storage piece. So I've kind of been going round and around with this, trying to figure out what the best way to deal with this is. MySQL as a database is pretty decent. And initially I was thinking of just dump all the Nmap data, put it in MySQL, and it's searchable, which is possible. I don't know how much benefit that gives you. I don't know, I haven't really looked to see if NDiff can do anything with that. But there's going to be a bunch of metadata that might be more usable for reports and quick searches and history and et cetera for the other stuff. So if we stored all the metadata in MySQL, that gives us at least a good base to start with. And then for the actual Nmap output, storing that in a revisioning system. Git seems to be what I'm using and a lot of people are using these days. SVN works. That's what Rancid uses. That works really well. But then you can have revisioning on all of this information. You can go back and look in the past. So obviously, whatever's here wouldn't be encrypted, but this is a central system. This should be protected already anyway. This would be the part where I would show you a demo, except I don't have a demo yet. These things take time to build, and unfortunately, summertime is our real busy time at a college. So despite best intentions, I did research, and that was about as far as I could get with this. So currently, I have a nice, pretty detailed design document. That'll be up shortly after the talk. And then, this slide deck will be up there as well. I will be, I am coding. There'll be something out there. Hopefully January 1 we'll have something out there, and then you'll be able to find information on it at this link. And I'm looking for assistance. So that's about all I have. I probably talked a little bit faster than I wanted to. So I'm looking for input, questions, suggestions, etc. Right, so we're looking at getting a view from the outside. So Nmap has other capabilities. I mean, you can dig into actually what services are running, et cetera, and that may provide additional input. But yeah, at the start, it's like, let's look at all the hosts on the network. Let's look at the ports that are there, and then monitor that over time. Let me know if something changes. Because again, it's if something changes and I don't know about it, not necessarily good. I mean, it could be a simple misconfiguration. I heard that happens. Or it could be that your network has been, penetrated by something and they've opened up IRC or whatever. And Nmap is kind of the first stage. I want to kind of try to build this into something bigger eventually. I'm familiar with Nmap. Like I said, I dabble in security, so I kind of know some of the bigger tools that are out there. If there's other stuff that can be used as well, that's great. We can add that in.
You mentioned issues like access issues because of monitoring your network segmentation. Are you envisioning this as like one central scanning host, or are you having various machines sprinting throughout the environment and they're feeding back to your repository?
Right. So you would have a central system that deals with all of the timing data and sending out the commands to your various different scanning hosts. So it is your scanning hosts themselves are not. It's not inside of the network. So you could pop up a VM on AWS. If you needed to, you can pop up a VM on, say, Windows Azure or something else, and then run those scans from there. And then all that data is then aggregated internally. It's possible. You're going to have different views from those different networks, and it's probably not a bad idea to understand the differences between them. I don't know how much, and on an automated basis, I'm not sure that's a real useful tool. But you should definitely have the ability to diff between multiple different scans. There's going to be a lot of noise. It may be that there's a lot that the faculty can see or students can see that the outside world can't, but that's I think more of a manual thing. But you'll have all the data there to be able to do that. So anyone else? So I appreciated listening to what I have to say. Sorry it was a little shorter than I wanted, but like I said, I'm nervous and you guys terrify me. So, thanks.